take one at the end, of course. I hope. That's everybody here. Got another %. And we're done. Okay, what was the last thing we did? Because then we got a note handy so I don't actually duplicate my work.
The last thing we did was talking about gathering data.
So gathering data, anything else?
A little bit on controlled experiments.
Okay, so we need to, I think that's probably the good place. That sounds to me like it's 1.3 then, the last part of chapter 1, right? So that'll be a good point for me to start. So I'm going to zoom over to, oh, I'm using the word zoom. I will nip over to here. Yay, picked the right one for a change. Let's go into our class. Are you all seeing chapter 1 module, your Canvas screen? Yeah. So if I click on chapter 1, and the first thing I'm going to show you is, you know this place where all the resources, major class stuff is. If we click on this one here, there's our first lecture. So if you want to go back and look over something, you certainly can. If we click on this guy, I don't know if this is going to work or not. Right, are you see? Well, give it a few seconds. Can you see the video?
Yes.
Here's a question. Can you hear the video? I can hear it, but I don't know if you can.
No.
No, okay. Okay. When you click on this video, there's something weird that I noticed. It's not on. Oh, shush, it's distracting me. You see these little icons, you know, closed captioning and this thing over here with the settings. You see these guys at the bottom here? If you hit the little one that is settings here, do you see that you actually get different resolutions? And right now it says normal, but if I click on it, I can have custom. And I noticed that when I was doing it, it was in a very poor quality resolution. And you can actually click on it and you can get much higher resolution. So if you're watching the video and it's this kind of very blurry look, will you click on that little icon guy and see if you can improve the quality as I could. And I just realized something that is scary. Closed captioning works. Do you see that? Good. Technology. That is kind of cool. I didn't realize it did that. So these videos also, you can now have closed captioning. I'm not sure if many of us need it, but it's nice to know that that's the case. So we are going to be looking at the final piece of the puzzle, which is going to be observational and experimental design, essentially. So let's minimize that one. There we are. Okay, my usual question, are you seeing a PDF, are you seeing a getting started and some cheers? Yay, good, okay. So let's look at, because they go into a lot more detail than we typically need to do, is let's look at the two major types of experiment that are used very often in the medical field. So I know quite a few of you are interested in the nursing program or at least something to do in the medical field, right? If you do that, what you'll find is that a lot of the evidence that they have to prove something is beneficial, uses this technique. There are two main types of experiments. The first type is called observational, and the second type is called an experiment. Now, in an observational study, you just essentially you watch. So I'll give you an example of an observational study. We all know and we all accept, I think, the scientific world accepts, medical world for sure, that smoking's bad for you, right? Increases your chances of getting lung cancer and actually lots of other things that are not good for you. So you might say, how did we actually get to the point where we could justify that that was true? And they had to do an observational study. What that meant is that they just collected data on everybody, right? People who smoked and people who didn't smoke. And they got medical records of how long they lived and what did they die of. And they got people who were heavy smokers and people who were moderate smokers and people who never smoked in their life. And they found out things like the people who never smoked in their life typically lived longer than heavy smokers. They found that the people who were heavy smokers, a larger proportion of them died of things that you would associate with smoking today, right? Lung cancer and that type of thing. And it was over a large amount of time that they built up enough evidence to prove that that was the case. Now, it's pretty obvious that smoking is bad for you, but can you imagine 40 years ago when people used to talk, you know, everybody in the movie smoked and smoking was just normal. I'm actually old enough to remember you could smoke in an aircraft. I mean, you think, God, no. Yeah, you could smoke in an aircraft. A lot of the industry, the smoking industry in particular, were not happy about people proving that smoking was bad for you because that was obviously going to reflect on their sales and their profits. And they put forward scientific explanations of why things like smoking, it wasn't the smoking that was bad for you. They can do anecdotal evidence. I can give you an anecdotal evidence right now that they could use. My father smoked his cigarettes and then later on pipe and cigars his entire life. In fact, I think he started smoking when he was 14. He died at 86. He did not die of anything to do with smoking. It wasn't lung cancer or something that we would associate with smoking. Right? My mother's brother, my uncle, never smoked a day in his life. And he died, I think, when he was in the early 40s of lung cancer. So do you see that nothing is clear cut in the real world? So people would say, well, that guy there smoked, he was 96, never got cancer. And this guy here never smokes in his life and he gets cancer. How could smoking be causing cancer, right? That was the kind of argument, right? The anecdotal evidence kind of argument. It's difficult to prove that. In fact, do you know the only way you could really prove smoking caused cancer if you weren't doing it observationally? Basically, you just proved it by overwhelming data, right? Forget about the little anecdotal ones. 99% of the people, this is what happened to them, right, when they smoked. That kind of evidence would be to do an experiment, and the experiments are not allowed for things like that. Show you how that would work for smoking. You'd have to get randomly 1,000 people, say, and split them into two groups. Totally random, right? So in each group there was healthy people, you know, marathon runners, and there were couch potatoes, right? And in the same in the other group. So the two groups were pretty much the same, right? A whole variation of all sorts of kind of people. You take the first group and you tell them to smoke 60 cigarettes a day, right? Make them, right? You can only do it in a communist country or a fascist country, right? Smoke 60 cigarettes a day. Go to the other group and say, you're not allowed to smoke a cigarette. You smoke a cigarette, I'll shoot you, right? You're not going to do it. And then you let those people do that for 20 or 30 years. And then you build up data on the percentage of each that died. And then you could say, the only thing that's different between those two groups is that one group smoked and the other didn't. You know, both groups lived their life the usual way, right? They still were marathon runners. Probably not many of the smokers would be at the end, but, you know, at least they started off that way. And so if the only difference between two groups is one thing, then that one thing must be the cause of the difference, if there is a difference in death rates or lung cancer rates or whatever. Can you see that many diseases cannot be done experimentally because that's the way you have to do it? You have to force people to do bad things to their body to get evidence to prove that's a bad thing to do to your body, right? You can't prove by experiment that drinking is bad for you, right? I'll pick one of my dislikes, cannabis smoking. I am sure cannabis smoking is going to be bad for you. Will we be able to prove it? Nope. We'll have to do an observational study on it, which means we'll have to wait 20 or 30 years of heavy use and big loads of data, and then we'll find out if I'm right or wrong. I'll probably be dead by then, but I'll be upstairs hopefully looking down and say, see, I was right. You might find out that cannabis smoking increases the schizophrenia rate. It may have effects on your mental acuity, right? If you drink, if you drink enough, it'll kill your brain cells. I'm sure if you smoke enough, it'll do a similar thing. So that's just my personal opinion. But I won't know that for about 30 years. They haven't got enough data on it yet. And I might be totally wrong. Who knows, maybe heavy cannabis smokers live longer than the rest of us. We'll find out. So an observational study, sorry?
Would an experiment like that have to also include people who just ate it? Or
I guess you would have to look at different versions of it. Do you just eat it? Do you make it into an oil and you drink it? I don't know. The different ways of consuming it. You could do that with smoking. Couldn't you say, well, what about the people who chew nicotine? They're not smoking it. I believe that gave you mouth cancer. A different problem, but still bad for you in a different way. Maybe less bad for you, that's probably true. So yeah, maybe drinking it or eating it is great and smoking it is bad. I don't know. You'll not, as I say, you'll not be able to tell until the future. Yeah. So observational studies tend to be long-term, and they tend to be fraught with anecdotal evidence that contradicts what you think is true. And so it's very difficult to get a body of evidence. Eventually you will. Eventually, if there's a big enough difference, you'll be able to prove it, right? On the other hand, experiments, the second way, is the way that most medical, when they can do it, prove something. So essentially what you do in an experiment is that you take a group of people and you split them into two, randomly. So let's have a story. I'm going to jump back to my whiteboard. That way I can write some things down as well. I'm going to do a pretend kind of process of how that would work. So, whoa, oh, we're cool. So just to be visual, you get a bunch of people. Let's say you got 1,000 people, and this 1,000 people have got cancer. Let's say they have got prostate cancer, so it's men. What you would do is that you would randomly assign them into two groups, typically of equal size, but actually you can get away with them not being equal, but typically 500 each. And we call one group the control group. And the second group here, this one here, they're called the experimental. Now, what happens is that the control group and the experimental, or sometimes called the treatment group, that's another name for them, get different things done to them. The experimental group always gets the new drug that you're interested in. So suppose they've got a new pill that you take if you've got prostate cancer, and it shrinks the cancer down, right? It helps you get, at least improves your chances of survival, right? And the control group, they get one of two things. It depends on the situation. They either get the old pill that you would get if there was an old pill for prostate cancer, or you would get what's called a placebo, right? You get a sugar pill that has no medical effect. Now, I know I did this last night with my other class, but I don't know if I did it with you. Did we talk about placebo last time? We did?
So.
Think so? Okay. So you got the two groups, and then what you do is you give them a trial. Now the trial could be a 3-month trial, it could be a 6-month trial, depends on what you decide is a useful amount of time. And then at the end you get your data. And your data will consist of some measurement of success or measurements of success. So it might consist of things, for instance, like percentage that are still alive at the end of the trial. It might be the percentage that are alive 2 years later. There may be other measures of success. Do you know that you can do CT scans and you can actually measure how big the tumor is? So you might have the data might be reduction in tumor size, right? So you collect an information and then you compare the two groups. And sometimes both groups are pretty much the same, which means that the new drug is not doing anything better or worse than the old drug. And sometimes, hopefully more likely than not, the new drug is more successful. And that then becomes your evidence. The two groups were roughly the same. They were treated for the most part the same. Only difference was one got this drug, the other got no drug, or they got the other drug. Therefore, the only difference was the treatment that they received. So if there was a reduction, it must have been the new drug that was the effect, right? It was the thing that was making this happen. Does that kind of make sense as a reasonable way of proving something in the medical world? Now, what would happen is that then that would get published in some medical journal, you know, the Prostate Cancer Journal of America or something. Some of these journals are extremely specific. You know, there's big ones like the Lancet where all sorts of things go, but it's hard to get published in that because you have to do some really big stuff to get noticed. And then you have the smaller journals that are specific to those people. And then the people who deal with that type of cancer, they would look that up and say, oh, that's interesting. I think we should look into that and maybe use that as our new drug treatment. And if they can then come back, and very often if a trial is successful, that's not the end of it, that's just the beginning. What then happens is that people in Czechoslovakia and France and somewhere else, China, do their own clinical trials. And if they can duplicate your results, that becomes even more relevant. And the medical world says, yeah, that new drug's great, let's use it. Or not, if the case may be. Because sometimes they don't use it because it's expensive and they wait till it becomes generic, for instance. We cool? Right. So you're going to have to look at the details of how that works. Tell you a true story here, which is to do with ethics. When I was at Glasgow University a long time ago, we were, I was doing a class, not teaching, I was actually a student. See, I was a student once in my life, getting things like this. And the guy that was there was telling us about a experiment that was being done in Denmark, and it was to do with prostate cancer, strangely enough. And they had a new treatment that they were trying out. And normally when you do a treatment, you don't just wait till the end of 6 months or the end of a year, because sometimes these clinical trials take a long time. You know, they take 6 months, a year before they're finished. You still do snapshots on the way, right? After 3 months, how things are going. After 6 months, how are things going, right? Anyway, this clinical trial that was done on prostate cancer of very, very sick people, people with a very large likelihood of dying. They were getting this treatment, and the new drug was horrible. They were actually dying quicker than the normal treatment that they were getting. And it was quite clear after 3 months that there was just carnage going on. And they continued the trial to the end, which meant that the people that were on this group here were getting treated with a drug that wasn't helping them, it was actually hurting them. And the ethics behind it was, I think, and totally wrong. This company was hoping that that was just bad luck, that if you kept taking the pill, eventually it wouldn't kill you. You know, because some drugs, especially in the chemotherapy world, they are extremely poisonous things, right? One of the ways that you kill cancer cells, this may or may not surprise you. Do you know cancer cells, we think of them as being really strong. Cancer cells are actually typically weaker than the normal healthy cells that they're trying to push out of the way. And so one of the tricks in chemotherapy is essentially you almost kill the body. And it's a kind of balancing act. You kill it down to the point where all the cells start dying. Almost all the cells start dying. But the cancer cells die first. And you stop before everybody else dies. And then you recover. That's one of the olden days. That's why, you know, chemotherapy was such a horrible thing to do to people, right? Because you basically were poisoning them to the point where the cancer cells would die first. And then you would stop the treatment, hopefully at the point where all the cancer cells had died and the, you know, the good cells had time to live. So those poor guys were dying. And the bottom line is that if you're in any kind of clinical trial, you're under an obligation to protect the people in your trial. So if you do an experiment and you find out that that new pill is useless, just pack up. Say, sorry guys, trial is over. Those guys that are left, go to that one. At least you've got a fighting chance. You might make it, right? Don't stick with this one. We'll probably kill you, right? Move over to that one. We'll give you a chance. And the ethics of that, it kind of makes sense, but it's not always followed. There are some countries, which I won't name, who are notoriously bad at not following the ethics. If you're in a country where there is an awful lot of control, you can get away with doing anything you like, and unfortunately they do. So that's my little spiel about that. So, so far so good.
I actually had a quick question
Go
about
for it.
what you talked about with your class last night on placebo, because I think we might have touched on it yesterday, but not expanded on it very much.
Okay, so you want to know a little bit more about the placebo?
Yes.
Right? Okay, now it's called the placebo effect. It's a very strange effect. It works better with some situations than others. If for instance, you were dealing with pain, you know, I want to take a pill, I've got a headache, or I want to take a pill because my back hurts, right? Those kinds of pain-related things. Placebo effect works really strong with them. What it says is that, say if you take a pill and you believe that that pill is going to reduce your pain, it can actually have a physical effect on you. You will feel less pain. Even if the pill has got nothing medical in it, it's just made out of sugar, right? It's a sugar pill. And they discovered that quite early on, and they called it the placebo effect. An analogy to that. Do you know when you were very young and your mum told you, she told me anyway, I used to get car sick when I was young, and my mum told me that if I rubbed the lobe of my ear, I wouldn't get car sick. And of course you believe your mum, and if you're young enough, you believe them even more, but when you're older, you maybe not. And so I believed my mum, and I used to rub my ear, and I actually didn't get car sick, at least that often. Now, you know, rubbing your ear has nothing at all physically to do with being, you know, motion sickness. But that was an example of the placebo effect. I believed it was going to do me some good. My brain believed it. My brain has got a lot to do with how you feel. Like nauseous, it's got a lot to deal with how you feel in pain. So that's what the placebo effect does. So when they do experiments and they have the two groups, one group, the one that is the control group, is very often given a placebo if it's possible. So if it's just minor headaches, you know, the new headache pill or, you know, the other one, you just get a sugar pill when the group that is getting the control group, right? If they don't know what pill they're getting, right? That's called a blind experiment. If the doctor that's treating them, finding out whether or not they've got, how much pain they're in, the doctor that's treating them, he doesn't know either. He doesn't know if you're getting the good pill, the new one, or whether you're getting a sugar pill. And when they do that, it's called a double-blind trial. So a lot of experiments, the control group don't know what treatment they're getting. They don't know if they're getting the real pill or the pretend pill. And the doctor, who's the person who's in charge of this, because very often you do these clinical trials with your own doctor, right? You receive the medication from your doctor. He checks up on how you're doing, that kind of thing. He doesn't know or she doesn't know either. And that's called the double-blind trial. And what that does is it takes care of this placebo effect, because if you don't know what you're getting, then you can't really have any issues with it. And the reason why they make it blind, it's not a good idea to tell the person, by the way, you're in a medical trial, but this pill's got sugar in it. It's not going to do anything, but we're using you as a control group, because then the placebo effect disappears. You got to believe that the pill's doing you good, right? It's going to do something before the effect kicks in. And do you know why they don't tell the doctor that's treating you that you're getting which type of pill you're getting? That's why it's a double blind, why he or she doesn't know that.
So he can't
Say again?
So he can't interpret the data favorably towards one way or the other?
That's true. I mean, he might want this new drug to be better than the old drug. There's a kind of wanting success. Nobody really wants to take part in a clinical trial that ends up saying it's not any good. And another reason that they do it is they found out that if the doctor knows, he doesn't cheat, but indirectly he tells the patient by body language. When he comes in, let's suppose you're doing a pain medication thing and you come in for your checkup and you've just done your pill thing, and he comes in and says, "And how are you feeling? How is your pain?" He sees, it's projecting I feel that you should be in pain, right? He's indirectly influencing the effect. So
eliminating the bias, right?
Yeah, you want to get rid of the bias. So you don't want him to influence your responses, and we don't want you to know what you're getting, so you don't influence your responses. It's very effective. If you can do a double-blind trial, pretty much you are on the road to proof. A lot of people, a lot of the new medications involve this process. That's typically how the FDA organize new drugs. They look at the structure of how you do it. They don't just say, a pharmaceutical company can't just come to the FDA and say, "Hey, we've got a new wonder drug, can we use it, please?" It doesn't work that way, right? The FDA says, okay, you got a lot of things, you got a lot of hurdles. The first hurdle you got to prove to me is do no harm, right? And remember, there's a drug called thalidomide. Anybody know that drug?
Vaguely,
right? It was given to mothers for a very innocuous reason. It was to try and help them with their morning sickness.
Oh, that's right. Yep.
Right.
Yep.
And it's such a minor thing. You would think, you could, suffer the morning sickness or not, right? But they gave it to them, and unfortunately, they didn't discover until too late that it was causing birth defects in the babies.
Yeah.
And it was a big issue. That kind of was the motivation behind, in the world, not just the FDA, of them being much stricter about checking that the pill doesn't have bad side effects, right? So you may be taking a pill that helps your prostate get smaller, but if at the same time it makes your blood pressure shoot through the roof, it's probably not a good pill, right?
So could you have bias, like if you had, say you're doing a double blind, but a company, they want to promote this pill even though they know it's bad, like even though they're doing the double blind, can that also, I'm sure that happens as well.
I'm going to try to say what you're saying. The pharmaceutical company will want to promote their drug, but they can't get they can't get to produce it and give it to doctors until there's been a clinical trial that has been shown to be done properly. Right.
Right.
So
Because, like, I know,
right.
yeah. Because, like, I know, like we were talking earlier about cannabis and, you know, how we haven't had a lot of studies. Well, it's not FDA regulated. It's actually technically a legal drug. So the only studies that can be done on it are people with bias that, you know, are pro for it, or, you know, anti against it. And so we don't have like a third party, neutral party just looking
you
at
would
it.
hope that one day the data will come in, not directly. What happens is that there are large groups of data being collected regularly on the health of Americans. And one of the things that they do is that doctors will report increases in diseases. So your typical doctor goes through all sorts of diseases, but if he suddenly notices that he's getting an increase in patients who need medical help because of schizophrenia, or he notices that he's getting a lot more people with lung cancer or prostate cancer or whatever it is, that information gets sent to the government, and the government will look at it in the big picture and say, what's going on here? Why is this increasing? And then they'll delve into it and they'll say, okay, what are these people like? What do they do in common? You know, is there something that they're all doing at the same time, or most of them are doing? And that tends to be the first sign. For instance, they didn't know anything about thalidomide drug until they started noting a large, weird increase in birth defects in kids. And they started saying, what the heck's going on here? You know, 5 years ago, we weren't getting this. Now we're getting a lot more of this, right? And they looked into it and they thought, oh, what treatments were these mothers getting? And they looked at the aspirins, and they looked at this, and they looked at that, and then this drug thalidomide kept on popping up. And that immediately got them saying, okay, we're in trouble. There is no guarantee of long-term danger to any drug. We are using lots of drugs today that are, as far as we know, safe. All that meant is that during the clinical trial, nothing weird happened to anybody, right? They got better on whatever it was. But if they take it for long term, right?
Yeah.
You might suddenly decide that it's okay to take steroids for 2 or 3 years. It's not a good idea to take them for 20 or 30 years. And so you don't know long-term things. So there's probably some drugs out there that we are taking today thinking there's not a problem with them. And it's only after long-term usage that we then discover that there's a problem.
I'm sure even in our diet with, you know, processed foods, that's what we're starting to see now more, is that there's leading evidence that it is causing issues in our bodies as well.
It may well do. These are all going to have to be observational, which makes it difficult to prove. You need quite a body of information. But yeah, I can imagine that there's probably some things that we take that we probably shouldn't be taking. There's some things I know are bad for you, but we still take them because they taste good. Right? I'm sure long-term fat intake is not good for me. I still like things that get fat in them. But right. Well, let's move on. Are we cool with the experiment stuff and what its structure is and what it looks like? Any questions about that right now? Are we good? Right, so what I'm going to do now is I'm going to go and we're going to look at some of the, if I can get this thing open, some of the homework questions, because very often that brings to light things I didn't do or didn't cover enough. I think it's here. And, okay. Here we are. I will do a view on this one. That looks good enough.
I was actually wondering, quick, does the control group have like both, or like are there two separate control groups with the old pill and the placebo?
No, the one group's called the control group, and they're
Yeah.
the people who get the placebo if it's possible. And the second group is called the control, and sometimes it's also called the treatment group.
The placebo group can also be the old drug, though, instead.
Yes, sometimes you can't not give someone, if you've got prostate cancer, the last thing in the world I want to get is a sugar pill. At least I want the old drug, right? So the control group, the best environment would be a placebo, but you can only really do that in, things like reducing my headache, right? Something that's not going to kill me, right? But typically the control group gets the old drug treatment, and the treatment group, or the experimental group, that's another name from it, they're the one that gets the new drug. And you can still do the placebo effect. If you're getting the new drug or the old drug, do you know they just make them the same pill? So they look the same and they taste the same and whatever else the same. So you can't even tell that you're not getting it. And that's just another way. They've done some really cool things before I move on and look at these questions. How the placebo effect works. It works really well with things like headaches, right, and pains, just general aches and pains, right? Placebo effect is not good if you break your arm. You break your arm, you're going to hurt like hell, right? There's no placebo effect that's probably going to make that not hurt. But if it's, again, I got a headache, a stress headache, I got a kink in my back, things that are pretty minor, placebo effect works better than that. But they've discovered psychologically, do you know if you're giving someone a pill, make it colourful, make it purple or red, and make it small. The placebo effect works stronger if you give them a tiny little purple pill or a tiny little red pill. Psychologically, you would think that's back to front. But the way it works, I think the way it works is small pills make you think, God, this must be powerful. Look at the size of that. It's a tiny thing. This must be a really heavy-duty painkiller, right? They wouldn't make it that small if it wasn't, right? And I think the colour's just psychological. Bland white, could be an aspirin. But purple or red, it's got something going on here, right? So if you want the placebo effect to be stronger, you make the pill small and you give it a colour. And they've just discovered that. They've actually done that by doing a placebo effect experiment. One group got the placebo, which was a poor, an aspirin-looking normal-sized pill, and the other group got the colourful tiny pill. And they were both told that they were going to, help their headache. And then they collected the data, and they found out how that placebo effect works. So we even know how to make placebo effect. I've got a feeling that some pills are deliberately using that as part of the process. Right? You get a pain-killing pill, they maybe make it small and purple or red or something, just to help you feel less pain. Kind of interesting reversal of process, using the placebo effect as part of a chemical reaction, right? As part of a real treatment. Okay, let's have a look at some of these questions. There's only 6 of them, so again, I know I did this with my last night class. Did I do this section with you lot? This is 3.3, the experimental design stuff. No? Okay.
I'm not seeing it. I'm only seeing the...
Oh, okay. And then I need to go out and in. Thanks for telling me that. You seeing it now?
Yes.
Okay. Okay, so question 1, consider a completely randomized experiment, right? So you break them into 2 groups randomly, in which the control group is given a placebo for congestion relief, okay? And the treatment is given a new drug, okay? Describe a double-blind procedure. And so they go on and they give us 4 descriptions, and one of these best fits what is called a double-blind. So let's see what they choose. Choices are. The patients did not know which treatment they received. Well, that is true, but isn't that only half the story? If that was the only thing that was true, so the doctor knew what pill you were getting, but you didn't, right? That wouldn't be called a double blind, that would be called a blind, right? Terminology. Second choice, neither the patient nor those administering the treatment know which patient received which treatment. I'm stopping there, isn't that a double blind? Now, can you imagine this was a test question? All you would be doing would be, I think you click that little guy and you're done, right? I wouldn't expect working for that. That wouldn't make sense. And then well, what are some of the benefits of doing this? And this time they say select all that apply. So if they don't mention select all, I'm assuming that means there's only one answer and you pick it. Oh, here's the thing, I'm going to try. I don't know if this works. Oh, okay, that's good. If there's only one choice, they only allow you to put one dot. Okay, now, here are some of the benefits. The first choice, or the first thing is, the process should eliminate potential bias from patient psychology regarding the benefits of the drug. The basic saying placebo effect, I would agree. That's one of the reasons. This process should eliminate potential bias from the researchers. The people administrating the test, we'll see about that. This process should eliminate potential bias from the patient's families. I don't know what that's about. This process should eliminate potential bias from the treatment administrators. Now, did you notice that I left the second one blank for a minute? The administrators don't know what drug you're getting. You don't know what drug you're getting. But researchers, they need to know what drug you're getting because they have to figure out which one did good and which one didn't. So the key here was researchers are not the same as treatment administrators. In fact, they shouldn't be if you want to be fair. So what you were talking about earlier, Rachel, is in those bias situations, do you know that the researchers are the treatment administrators as well? You know,
really?
you can imagine not only are they performing the experiment, they're actually recording the data coming from that experiment.
How often does that happen?
It shouldn't happen at all. It's
Yeah,
the short answer.
I'm
If it did
Yeah.
happen, it would be laughed. You couldn't publish it. If you published it, people would laugh at you. They would say, you're the guy that's collecting the data to tell me that this is working. We need someone independent to collect that. Otherwise,
Right.
I don't know how honest you are. How can I really trust the data? And you might get away with it once, but if you did it, you would destroy your career. I mean, if you cheated, right? There have been examples of not medical world that I know of, but I definitely know in the science world where people essentially, because they're in charge of the collecting of the data, essentially cheated. There's a great story of one scientist doing an experiment and he was getting various results and he threw out all the results that didn't agree with what he thought should happen. And he only kept the ones that fitted what his model, his formula says, because he wanted it to be true, right? So the ones that didn't fit were, inverted commas, experimental error, right? And the ones that did fit the model were good. Now, that's not good for your long-term career, because what happens is people duplicate what you did and they don't throw away the weird stuff. And it totally contradicted his theory and he was just wrong. What he wanted to be true wasn't necessarily so. Right, we'll look at something here. Right, now here's something I haven't covered, so I want to make sure we do. We haven't talked about simulation, really. And we haven't, we've kind of talked about sampling and we have talked about census. So what technique for gathering data do you think would be used in these studies? So the first one, the analysis of a sample of 31 patients from New York hospitals suggests that poor and elderly sue for malpractice at 1/5 the rate of wealthy patients. So if you go to hospital and something doesn't work out right, elderly patients don't tend to sue and poor people don't tend to sue. But if you're rich, you sue them all the time. I'm exaggerating, but that's what it's saying, right? And how do you think this evidence was probably collected? Well, let's start at the bottom. It's a census. Well, I can tell you right now it's not a census because it was only a sample of 31,000 patients. They didn't look at every single patient in New York. And to be a census, it would say they looked at every single patient in New York and they found that the poor and elderly sued at less rate than the rich. Right? That's how that would be phrased. So I'm kicking it out by a process of it ain't you. Right? Now, moving upwards, the new guy called simulation. Simulation means you don't physically do the thing. What you do is you get some computer software to run lots and lots of experiments for you, right? So they have a computer model. Give you an example. It's not a good idea to test car crashing with real cars. It's extremely expensive. They do it a couple of times, but normally, do you know what they do? Is they have a model of what the car is, right? A very complicated 3D model of what the car is. And then they pretend by computer programs to smash it into things, like smashing into poles and smashing it into cars. And then they use physical formulas to figure out what would be the damage done to a car, and if there was a person inside it, what kind of forces would be exerted on them. And you can run these simulations lots and lots of times, and that's what a simulation would look like. So if you ever see a story where they talk about computers being used, you're looking at a simulation there. So I'm kicking that one out. Now, it's a sample or an experiment. It could be one or it might be the other. In this case here, I'm going to say that this thing here was a sample. There isn't any evidence that they took 31,000 patients and split them into two groups and sent them to the hospital and found out which ones, you know, sued more than the other, right? So there wasn't a lot of detail. If it was going to be an experiment, they'd have to mention things about the doctor didn't know or the patient didn't know, and there was two groups and this happened and that happened, right? There'd be a lot more details. So B, the effect of wind shear on an aircraft during both landing and takeoff were studied by using a complex computer program. I'm stopping right there. Simulation. Right? C, a study of all league football scores. I'm stopping there. I don't need to read the rest. A study of all league football scores. It's a census. Right? Sometimes it's just one word. In this case, all. And the one before wasn't the computer, the kind of giveaway. Now, sampling and experiment are probably the two that you're going to have the hardest time separating from. So look at D. An Australian study included 588 men and women who already had some precancerous skin lesions. Half got a cream, the other half got some factor, and the other half got something else, right? So can you see that the preamble here has got a lot to do with the experiment? If I go into it, it looks like that's a double-blind experiment, although they never gave me that as a choice. Why is it a double-blind experiment? Well, would you agree that there's two groups, but doesn't one group get a cream with all the good stuff in it? That would be the experimental group. And doesn't the other just get an inactive sunscreen that doesn't really do much? That would be your control group. And I'm pretty sure, I'm reading into this, that you don't know which cream you've got. They just give you a bottle and say, use this stuff. And we'll assume that the doctor, when you go and visit your doctor, doesn't know which cream you were getting either. So do you see how you can look at these four choices and decide which one is being used? Does that make sense? Right. And which one of these two shall I look at?
Is a sampling the same as a observational study?
Not necessarily,
okay.
no. A sampling just means you grab 400 people and you do something to them, right? An experiment is much more structured than that. In fact, none of these questions gave you an observational choice. They could have put an extra dot and said observational. I think that would have been a valid question. But if they did that, they'd have to say things like, a psychologist watched a group of school children for 2 hours and he recorded how many times a child hit another child. Right? that would be an observational. Right? You're really not doing anything except looking. Right? That's what observational is. But even if you go into the details, although the book doesn't go into it much, if you do observational, there are actually different kinds of observational. There is observational where you go back in time. In other words, you suddenly decide, why is there so many more children with ADHD? Why are there so many more than there used to be? And you go back and you search what the figures looked like 30 years ago, by people that were diagnosed in that way, and then see if there's anything changed in the the lifestyle of the pattern. I mean, there's one that I know right now, I can't remember where I've read it, it's kind of interesting, but asthma rates have increased in the last 20 years. The number of people who have asthma.
Could it also be because of the more testing that we're able to do?
Totally. That's one of that particular one. That's exactly one of the reasons they came up with. They don't think there's anything particularly changed. It's just that if you test more, or you're more aware that that's what it is. Sometimes they used to say, you just got a kid. That's just your kid, right? That's just what they're like, right? A lot of them just got that. And they're much more sophisticated today as well. So, because nothing is you've got it or you've not, isn't there a kind of spectrum of you've got a severe case of it or a mild case of it or all the other things in between.
Right. It's the same with like autism, that there is more awareness as well as more testing.
Yes. So it's not, yes. And I think the body of evidence is that it's probably not increasing. It's more likely. On the other hand, I don't think asthma falls into that category. I think you have asthma, pretty obvious when you've got it. I have it, for instance. I know I've got it, right? So they're wondering what the cause of that. It might be an air quality issue. Maybe the air quality is not as good, but I don't know if that's it. I haven't seen evidence, but that's kind of what it is. All right. I'm trying to think of a good story here. I want to do a placebo one, but we don't have too many choices, and I'm kind of using up all the good ones. Okay, let's pick this one. B. The Denver Police Department wants to improve its image with teenagers, so a uniformed officer is sent to a school 1 day a week for 10 weeks. Each day the officer visits with students, eats lunch with them, attends pep rallies, and basically just joins in. There are 18 schools, but the police department can only visit half of these schools this semester. A survey regarding how teachers view police is sent to all 18 schools at the end of the semester. So, if I've got this story right, there's 18 schools, 9 of them get policemen and the other 9 don't. And then they have a kind of survey that they go out and they say to them, in a scale of 1 to 10, what do you think about police, right? And they collect data on the view of the school, right? So the average score for school A is 8, and the next one, the school, is 10. Give them a scale, 1 to 5, 1 to 10, and you've got the data. So that's what I think is going on. So let's see what is going on here. The first thing says no placebo is being used. Would you agree in this story there isn't a placebo? You know if you're getting a policeman at your school, and you know if you're not. So no placebo. After the police visits, survey all the schools to see if there is a difference in view between the two groups. Yeah, I think that's what you do. A placebo is used in the remaining 9. No, it's not. After the police visit, survey 9 schools to see if there is a difference of view between the two groups. I should check this one. After the police visit, survey all the schools to see if there is a difference in views. After the police visit, survey 9 of the schools. I don't know why you would do that. Use a random selection to pick them. That is certainly true, shouldn't you? You've got 18 to pick, you should just random. You don't want to pick all the nice schools in the really rich area and send police there, and all the inner city schools, and don't send them there, right? There could be differences.
Shouldn't it be the next one?
And you're right. It should be that one. So can you see, you just read the story and you try and make some kind of sense of it. And that's going to be the end of that section. I want you to start the next one, which is graphical representation of data.
I had a question real quick about the
Sure.
homework on 1.3. So in the those last 3 questions,
Yes.
what how were we supposed to? Were we just supposed to randomly answer it, or is there a specific thing that we're supposed to put in? I wasn't sure how to
Well, in
answer
those
it.
questions, that last one, the one that's kind of disappeared now, you check the box, Mark, you check the boxes of those things that apply to that story. So there was lots of, you had 6 things and you picked 2 or 3 of them, depending on which ones were true.
No, the final question had boxes where you put
Oh.
yes or no.
Yeah.
I'm not sure
Yeah.
why they didn't just have
Yeah.
yes and no.
Sorry.
I do not know that that was a question. Let me go very quickly.
I was looking at it last night and I'm like, I don't know how to answer this.
And once
Oh,
again,
I think I remember now. Yes. Okay. So I'm going to bring that question up so everyone can see it, because it's probably not a good idea for me just to talk about it if you can't see what I'm talking about. So I believe it's this question here, right? The New York Times one. It's got boxes in it. Can you see the
Yeah.
one I'm talking? It's this one you're
Yeah.
talking about. Okay. So let's do the intro to it. The New York Times did a special report on polling. It was carried in papers across the nation. The article pointed out how readily the results of a survey can be manipulated. Yep, you knew that. Some features that can influence the result of a poll include the following: the number of possible responses, the phrasing of the question, the sampling technique used, voluntary response, sample design, all sorts of things, the fact that words mean different things to different people, and the questions that precede the question of interest. And finally, the fact that respondents can offer opinions on issues they know nothing about, which is probably me. I have an opinion on everything, even if I don't know anything about it. Now, consider this expression. Over the last few years, do you think that this expression means the same to everybody?
Nope.
No. Right. For some of you, it might mean that. For others, this. So no, it could mean different things. So I would say no. So that would be the end of that question. What would be a more precise phrase? How about something with a number over it? And if you use a word rather than a number, it can be vague, right? Big, small, a lot, not a lot. Increase, decrease. They don't really have a strong enough meaning. Technically, couldn't you say unemployment is increasing? And it might just mean one more American is unemployed than was unemployed last week. And it is increasing. But psychologically, doesn't it sound like something bigger is happening? So if you said one more person is unemployed than was unemployed last week, I think you're being specific and people get the true meaning. Now, the boxes here. Consider this question. Do you think fines for running stop signs should be doubled? Do you think the response would be different if the question had been phrased, have you ever run a stop sign, preceded by that question? So imagine you just said, should running a stop sign being doubled? And people would say, yeah, you're right, I think they should double it. Or if you went and said first, have you ever run a stop sign? And the person said, yeah. And then the second question was, do you think stop signs should be doubled? Do you see the first question is maybe going to influence your answer to the second question? I don't think I want to get doubled the next time I do that. So I probably don't want you to double it, right? And I could do it the other way. Do you know that 20% of all accidents are caused by people running the stop line, right? The stop lights. Do you think we should double the fines on stop things? You see, by telling you that, you're saying, yeah, let's try and slow this. I didn't realize that many people were getting hurt. Yeah. If you ever see a question that has a preamble, they tell you something and then they ask you the question. They are very often trying to do that to you. They're trying to get an answer out of you that is going one direction rather than the other. Be on the lookout for what are sometimes called power words, right? A power word is a word that is a strong word that has a lot of meaning, very significant meaning to people. So to give you an example, suppose you wanted to know about people's opinion on capital punishment, right? Being executed for committing certain crimes, right? Capital punishment. If I went and said, are you in favour of the government murdering people for committing crimes? Are you in favour of people executing people for committing crimes? Are you in favour of people, the government punishing people for committing heinous crimes? You see that the word execute, murder, kill, punish are the power word, and those words are going to influence you in your decisions, right?
The question though, what do we write in the box? Because
you write down in English your explanation of why you think that is a yes, if you think it's a yes. Or
okay.
you may not agree with me, and that's fine. All you would write in that box is, I don't think it would make that much difference. And this is my reason why I said that.
Because I already did this, but I just wrote yes and no because it didn't say right
It
an
wasn't
explanation.
specific. You won't be, yeah, they don't grade this part of the question, so it's not like you'll lose points. I would strongly suggest if this same question appears on the test, I would like to see a written explanation, because then I will be grading you. I am a human being, I can understand what you've said or not said. So yeses and nos won't really matter for the homework, but it would be a good idea to just get practice at verbalizing your thought process of why you agree or disagree with any particular statement. Does that make sense?
Yeah, thank you so much.
Right. Now that we're talking about those influences, did I go over all the different things that we can do to influence a sample, how it can go biased on? Did we do non-responders, for instance, and things like that?
Yes, you said that if there were, sorry.
Yeah.
We touched on it, but I actually have a question about that, because
Go
in
for
the
it.
chapter 1 review, there's a question where it's about the non-response rate biases study, and there's two options that I think could both be correct, and I wanted to clarify why one is not.
Okay.
The correct answer is supposed to be that people choosing not to respond may bias a study, and that people choosing to respond may bias a study is not a correct answer for that question. But I thought both.
But the reason why that is not a correct answer in this situation is the preamble to that was to do with non-responders, wasn't it?
Yeah.
Right,
But
if you're a non-responder, then you're not answering the question.
Okay.
So it's a kind of contradiction to say, I'm not answering the question, but I'm answering the question. Because people who volunteer to answer, they don't say, hey, I'm going to give you an answer. What is it? Oh, I'm not telling you. Right, I get, I mean, that's the way I'm reading it anyway.
So the difference is between voluntary response versus non-response?
Yeah, voluntary response are people who volunteer to tell you their answer. A good example of that would be, see if you're watching a TV show and the guy says, log into www.tellmewhatyoutthink.com and take part in that survey. Then you choose to go online and do the survey, right? So you're a voluntary response. I could watch that same TV program and say, nah, not interested in, right? So I'm not responding, right? So definitely a voluntary response would be in a situation like the TV program saying, go to this site and vote. You might have seen that sometimes. A better example of a non-responder would be when you physically tell someone or ask someone the question and then they say, no, I ain't telling you. That would be a non-responder. So you meet someone in the street with a little clipboard and they say, what's your opinion of abortion? And you say, I'm not telling you, it's none of your business. that would be a non-responder, right? And you see a difference between the voluntary response person then and a non-responder?
I do. I guess my question is also that, so if you walk up to someone in the street and say, you know, what's your opinion on abortion? The people who choose to respond may
Are the ones that are going to answer, yeah. Yes, yeah,
Right.
yes.
So isn't both of those things biasing? Who chooses to respond and who doesn't choose to respond? Both could create bias?
The way you're phrasing that, it does sound that way. I think we have to make a little distinction in the sense that in every situation, if someone gives you an answer, then they're responding. A voluntary response is when the person goes out of their way to find you, to tell you the answer. If you're the one that initiates the question, then you're not a voluntary responser anymore. You're being asked the question. I think that's the subtle difference, right? So if someone stops you in the street and asks you a question, if you answer that question, you're not really a voluntary responder. You're just someone who's answering the question. If, on the other hand, they have a big sign on a door saying, come to room 14 and tell us what you think, now you're a voluntary responder because you could choose to or not choose to turn up. And you go there and you then give your opinion. So there is a difference between the two, right? So I know the way your brain is thinking, but try and think about if you get asked a question, you didn't choose to be asked, you were just asked. Answering that question does not make you a voluntary responder. It just makes you a normal person, right? A typical person from the sample. Are we good? Right. So we are going to be looking at our next piece of the puzzle is graphing stuff. Checking how long we've got. We've got a little bit of time. Can this go away now? Are we cool with this? Okay. So we're going to look at graphical representation and tables. Essentially, how do you summarize the information that you've collected? So I want you to imagine that I was given the job by my boss, and your boss said, look, I want to find out how happy the people who work for me are. And so you go out there and you conduct some kind of survey or whatever it might be, and you collect your data. And we'll do the Likert scale. Oops. Ever heard of the Likert scale? It's used a lot in social sciences and things. You might not have heard the name, but you've probably heard or seen it. Do you know the kind of thing where you have a scale? It's typically 1 to 5. And 1 is, well, it depends on the question. 1, 2, 3, 4, 5. So 1 is definitely against. And 5 is definitely for. And 3 is, you know, so-so. Yeah, that kind of thing, right? So I've had it happen to me quite a lot. You know, I'm doing my bank thing. You know, I'm doing it by the phone, and at the end they say you've been chosen to do a voluntary assessment of how the things went. You know, the kind of thing, and you go in and they say something like, on a scale of 1 to 5, where 1 means you were totally satisfied and 5 means you were totally dissatisfied. You know the kind of thing? That's a Likert scale. And you say 1 if you think it was great, and 3 if it was, yeah, it was okay, but it wasn't great, and 5 is they didn't help me one darn bit, right? And you do this, it's called a Likert scale. So you collect the Likert scale, and you get these, this is the data that you get. Right, and this data is 500 people that work for your company, right? And you go back to your boss and you hand them 20 bits of paper that's got numbers on it. And you know what your boss is going to do? He's going to hand you back the piece of paper and say, that's no use to me. I want to know, you know, how happy people are at my job, right? What's it like to work for us? You can see that what you really need to do, and this is called your raw data, that you need to summarize it, right? You need to find a way to put that same information in a format that makes it easier for us to see what the heck is going on. So one of the ways you can do it is that you can do a frequency table. Now, you may have seen a frequency table before. I'll call this score, which means what they said in the thing. So I guess in this case, it's 1 can be, I love working for my company, right? And 5 is, you know, I hate it, get me out of here, right? That kind of scale, 1 to 5. And you have a score, and then you have a second column, which is called the frequency. Hence the name frequency table. And you do 1, 2, 3, 4, and finally 5. And in this particular way of getting the data, can we pretend that the numbers were 100, 70, 60, what's that, 230, 290. There we go. Let's check. 2, 3, 4. Right, I think that's 500. It better be. Now, when you see this, can you then at least get a better idea of what the kind of responses that people gave? 100 people who work for me love the company. That's not such a good number. 210 hate working for me. That would probably be an indication to me that I have some work to do at trying to find out why people don't like their job. Is it anything I can affect? There's one really good way which you don't typically do, but I could improve this a lot. Why don't I just double everybody's salary? That would probably help, right? You might hate your job, but if you love the money, won't you probably not hate it anywhere near as much, for instance? But it might be simple things that doesn't need financing. Maybe it's just the hours are awkward. You know, if you've got a family, certain time windows are really awkward. You know, I like to take my kids to school and then go to work. Well, it's no good if you start an hour before my kids go to school. You know, that just makes your life awkward, doesn't it? So maybe it's a simple thing of flexi time would work. You know, the day can start a little bit later. Maybe just doing things like that. I know that it's a big thing now, and probably it's going to become even a bigger thing working at home. If it's possible and you can do your job at home, doesn't that make a lot of the other things you do in life a little bit easier? And the flex time as well. So the guy would look at that and he would say, okay, I got work to do. Now, if you took that same table, you could create a visual representation of it. The vertical axis would be frequency, and the horizontal axis would be score. And you might do a score of 1, let's say. Can you imagine there's a scale going up here? That's 100, there's 1. And then the next score is 70. Next score is 60. Next one is 60. And then you finish away up here. You score a 5. Can you see that this picture here is a histogram? Is a visual representation of the same information. And a lot of human beings, they can look at this and it's easier for them to see patterns and trends. They can look at that and say, yeah, that looks really big compared to everything else that is sticking, you know, standing out like a sore thumb. So you have a frequency table and you have a histogram. That would be a table way of summarizing your data. This would be a visual, graphical way of doing your data. There are other versions of that picture. Most mathematicians and statisticians hate these things, you know, pie graphs, where you take a pie and you split it into chunks. So you put a 5 in here, and then you put 4 in here, and then you put 3 in here, and you put 2 in here, and you put a 1 in here. Yeah, it looks something like that. That's a different picture of the same data. Why don't we like this? It's very difficult to tell how many people said 5. Unless you do a little bracket and you put 210 inside it, I guess you could tell it that way. At least this way, can't you read off if the scale and the vertical's reasonable? Now let's look at another way of summarizing your data. Imagine that you have a whole load of data and it's to do with people's ages. Now, I could do a frequency table where every person or every age was given its own row. So you start at, say, 14-year-olds, 15-year-olds, 16-year-olds. Now, this is the problem, 75-year-old. If you did this, wouldn't this table be huge? It'd be tall. Isn't there also a really good chance that quite a lot of the numbers wouldn't even have a person in them? There'd be 0 people who were 74 years old. If you did this type of table with this data, right, it's just as bad as just giving people a list of numbers, isn't it? You can't really get much. The table's too big. Most of the numbers are 0, an odd 1 or 2. Not a good way of tackling the information. So what you do instead is you do what's called a grouped frequency table. And you still do the age, and you still do the frequency. But you tackle the problem a different way. You go 10 to 20, 20 to 30, 30 to 40, 40 to 50, 50 to 60, almost finished.
Question.
Yes.
Then wouldn't it be 21 to 30? Because
I hear what you're getting at. Yes. No, is the short answer, but yes, in some cases. Sometimes this goes 10 to 19, 20 to 29, 30 to 39, and so on, right? It's more common to actually have this number and this number the same. So these are called groups. The end of the first group is the same number as the start of the next group. And all you do here is that you measure this here as meaning 10 up to, but not including, it's a big phrase here, 20. Now you may say, well, why are we being nitpicky in these examples here? People's ages, if you tell someone how old you are, you tend to say, I'm 24, right? I'm 57. Unless you're a kid, in which case you'll say, 5 years, 2 months, and 3 days, right? Because they want to get old quick, right? But technically speaking, if your age is 35, do you know you're not really 35? Aren't you 35.213? If you're being accurate about it, aren't you? Unless your birthday's today, in which case I guess you are 21.0 or whatever, right? So what that allows us to do is that anybody up to, but not 20 years old. So if you're 19 years old and tomorrow's your birthday, you're going to be in that group. So it's 10-year-old up to, but not including 20. 20-year-old up to, but not including 30. Now, let's pretend that we had numbers and they look something like this. That would be an example of a grouped frequency table. Now, if you were saying, well, how can I draw a histogram of that? Well, it's not that difficult to do. You go 10, 20, 30, 40, 50, 60. Of course, I didn't plan ahead here. 70, 80. And the first group is 4, 10 to 20. 1, 2, 3, 4. And then the next group, the 20 to 30s, is a little bit higher, 5. The next group is a little bit higher, 6. Next group is noticeably higher. Next group, 3, 2, and 1. So do you see that 10 to 20, 20 to 30, 30 to 40, 40 to 50, do you see how it fits well with the diagram on the bottom there? If you did 10 to 19, wouldn't you have to call each one its own funny little label? And that's not as clean. Plus, well, I guess I've changed my mind a bit. I was going to say, what do you do if you're 19 and a half, I guess. If you're 19 and a half, you probably count as a 19-year-old. Right, so that's why I changed my mind. But this is the typical way in which you do grouped frequency tables. And it's a visual way of representing the table. Now, there are quite a few other different kinds of graphs and charts that we'll go into next week. But I've got enough time, I think, to show you what that would look like from some of my notes here. Wrong place. We're in chapter 2 now. Come on, there we go. This one here is just some notes to show you different kinds of charts depending on what the data looks like. The ones I've just finished doing, those data points that I was giving you there, they were all ratio data, right? You know, an age, how old you are is ratio, right? A 10-year-old is twice as old as a 5-year-old, and it doesn't matter whether you count their age in days, weeks, months, or years, it's still fixed, right? This particular set of data is how you deal with categorical data. So this is actually real data from the Titanic, if you've seen the movie, as I remember from last night. What it tells you is first-class people. There was 325 people aboard the Titanic who had first-class tickets. 203 of them survived the sinking of the Titanic and 122 died. If you were the crew members, there were 885 crew members on that ship. 212 of them actually lived and 673 of them died. And if you look at the second class and then finally the third class, you can see that there is a distinct difference in the survival rate depending on what kind of ticket you had on the Titanic, or whether you were a crew member for that matter, and whether you lived or died after it got sunk. Now, if you just take the frequency bar chart and you look at this data here, this one here is just showing you the proportions of total number of people. So they were using these numbers along the bottom here, right? These guys here. And what you do when the data is categorical, in this case, is this ordinal or nominal?
Ordinal.
Right. So it's definitely things, so it's nominal. Would you agree that that would be a reasonable order to put things in? They're a kind of natural order, so that's why I would go that. Do you notice that you put little gaps between things which are categorical, ordinal, right? And when you do that, it's called a bar chart, and you stick the word frequency in front of all of these things because it's how many people are in first class. And in this case here, if you take each of these and you convert them into percentages, what percentage of the total were first class? It's that number. What percentage of the total were the crew? Can you see about 40% of everybody on the Titanic was actually a member of the crew? right? So it was quite labor intensive in those days. These things here are basically, you put these guys like on top of each other. I do not like segmented bar charts. That's what these are called. But as a way you can compare them, the height of the rectangle for each colour represents the percentage of people. So for instance, if you look at this one, that's the percentage who lived. Out of all the people who are alive, that's the percentage of crew who lived, and that's the percentage of all the people who died. And here is an example of that same information.
And you said that's ordinal, not nominal?
What I'm saying, it has an order to it. So if you've got an order to it, right, you can do ordinal, right? I would say anyway that first, second, and third definitely have an order to it, and I think I could argue that the crew probably should go fourth. So I would say that was the case. I don't think they'll ever ask you that, but it was just putting it in. Right, I'm going to go through, zooming through this. There are all sorts of different ways you can get to it, and I'll maybe not have time for that one. But let's just finish on one of the biggest failures that happen. I guess I'll finish on this chart here. And that is that you do everything correct in statistics, right? You get a good sample, you get good information, you do everything right. And then the final stage, interpretation. What does it mean? I've got the data in front of me. What is it telling me? Because that kind of depends on the person who's looking at the data. I'll give you a very exaggerated view of what I'm getting at here. When you look at this data, no one would argue, I think, that first-class passengers had a much higher success rate, right? More of them lived, percentage-wise, right, than, for instance, the crew. That is a fact, right? Percentage-wise, roughly, very roughly, 2/3 of the first-class passengers lived, and about 1/4 of the crew lived. You see, there's a definitely disparity there. And that's a fact. Now, interpretation. These are my two exaggerated, and I'm emphasizing, I'm exaggerating this. That shows you what I already knew. Rich people can't be trusted. You see all those first-class passengers? They get treated differently. See, when the boats were getting filled in, first class got priority. They got on the boat first. And the riffraff and the crew, they had to just scramble for the spaces that were left. That's what that is telling me. Right? You could argue that, I guess. You could argue, different perspective. I totally agree that, you know, first class lived higher than the crew. Here's some other reasons why that could happen. Where do the first class passengers actually live on the boat? Well, when you're first class, you live high up with doors that open to the balconies or doors that open to the walkway where, guess what? The lifeboats are. And in the middle of the night, when you hit an iceberg and you've got like 5 minutes to get out of there, you've got a lot more opportunity to get out of there. And what about the second class? Well, they're not quite as lucky. They won't be on the top level. They'll be in, like, you know, 2 stories down, but you only have a couple of stairs and you're there. Now, where in the olden days did the third class passengers stay? Bills of the earth, right? Little portholes, you know, 8 floors down. How hard is it to get up 8 flights of stairs on a capsizing ship where you get 5 minutes to get to the safety? What about the crew, right? Well, 2 reasons for the crew. First is, aren't a lot of the crew working the engines, so they're even further down? Weren't a lot of the crew probably trying to plug holes in the boat to stop the thing from sinking? Weren't a lot of the crew given the job of making sure passengers got on the boat before they did? Can you see why the differences in survival rate isn't directly connected to being first class? It's connected to where you were on the boat when it hit.
But couldn't you argue that they still had the privilege to have first class to be there?
Oh yeah, you could say that. But let's change the world. Suppose on really clever cruise ships, the first class cabins were really low down and they were big.
Mm. Yeah.
In that world, wouldn't a lot of the third class passengers who had to stay, and if you go back far enough, do you know that some people, when they came across, the places that were the worst places were the ones right out in front, right on top of the sailboat? So when they hit an iceberg, actually they probably lived more than the poor, not the poor, but the people in the nice underground, cabins that were nice and comfortable until you hit an iceberg. So it's yes, it is connected to why were they where they were. It's because they were first class, but wasn't the reason for them living was where they were. Right. So I mean, it's pedant. It's being pernickety. But can you see? It's all to do with interpretation. It's not that my first story was right or wrong, or that my second story was right or wrong, or maybe the truth is somewhere between those two extremes. I don't know. It's just that when you let a politician near data, do you know they'll put spin on it? They will look at the same figures and very often come up with totally contradictory reasons for what that is telling you. And what you have to be able to do here is, as best you can, eliminate your own bias from what you want to be true, and then just look at the data and say, is it telling me, what is it telling me, and try and be as unbiased as you can. And that is a very difficult thing to do, because one of the things most human beings don't even know is that we are biased. We all hope that we're very unbiased people, but
psychology tells us we all have biases. So
yeah, so being aware of it is a good step. I'm not quite sure how you undo that, but at least you're aware of it.
Yeah, they actually, I took psychology in the fall, and they said, my professor said you could take, there's an online class you can take, and it'll show you, test your biases, and it'll come up and show which biases you do have.
Right. So that when anything happens that are connected to those biases, I have to be extra careful. So, yeah, I can totally understand that. The way that you're brought up and where you were brought up has a very big influence on what your biases are. So I can share a couple of things with you to show you where my biases came from. My dad was a coal miner all his entire working life, and we lived in poverty essentially. I was one of 10 children. My dad left school when he was 14 to work down the mine. He didn't even work on the surface. He was down the mine working. And my mum left school when she was 12 because her mother died in childbirth, and my mother had to become the new mother. And so when people tell me that, I got to where I am, I'm being biased here, which I am, basically through a lot of hard work. Our family, because we didn't have money, it would have been much better if I had left school at 16 and got a job and made some money and contributed to the house. But my mum and my dad made the sacrifice of, we can do without that money because we want you to get an education. And so, I'm forever grateful for that. And it was hard because you didn't have money. And I'll give you some examples. We never had a fridge until I started making money. My mum and dad never owned a car, never learnt to drive a car, never had a telephone. Just some examples of what we didn't have, right? And we stayed in an area where nobody else had them either, so in a way we didn't really feel neglected. And so I went through university and I did all my hard work. And so one of my biases is that when people tell me that I got it easy and I've got this job because of who I am and what I am, it tends to grate on me, because they don't know my life and they don't know what I had to do to get to where I am. And so I don't feel guilty about having the job I've got. I love the job I've got, but I don't think I got the job for any other reason except what I did. And so that's my bias, and everyone has their own. You come from different perspectives, and I know people have had a worse. I was not the poorest people. The poorest people were the people who lived next door to me. We always had food. I was never hungry. But the people next door, the kids there, sometimes they never got fed. That was a totally different, life to live. And that's a depressing thought. We need to finish on a joke, don't we? You ready?
Yep.
Right, one joke, perfect timing. We'll be finished at the end of this. So where am I going with my joke? Did I tell you the one about the Scotsman, the Englishman, and the American who died and went to heaven?
Mm-mm.
Oh God, you're going to I'm warning you right up front here. You ready? Here we go. Right, I am telling you right now, be aware of this bad joke. So they die and they go to heaven, and they're looking around heaven, and it's a wonderful place. And the Scottish guy's dead excited because heaven is huge, and he's all jumping up and down and can hardly control himself. And he finally says to St. Peter, who was the one that was showing them around, he says, "Heaven's really big. Do we get a car to get round? Do we get a car? I'd love a car." And St. Peter says, "Funny you should say that. You do. You get transport." And the Scots guy said, "Can I get any car I like? I want any car I want." And he says, "Well, it doesn't kind of work that way. What we do is we ask you a question. And depends on the answer what kind of car you get." And so they says, "Okay," nod. And so he goes to the Scotsman first and says, "How many times were you unfaithful to your wife?" And the Scots guy says, "I was never unfaithful to my wife." And he has this little book and says, "You're right. We have it down here." Scots guy says, "Well, what kind of car did I get?" He says, "You get the top of the range. You get a big convertible sports car, red, all the trims." And it magically appears and he jumps in, boom, he's off. And they go to the Englishman, same question, "How many times were you unfaithful?" And he said, "It was just once, and she forgave me. Just once, that was it." And the Englishman kind of says, "Well, what kind of car am I getting?" He says, "Well, you're not getting that one. You're not getting the Scots guy's car. We'll just give you a normal Ford, right? 4-door. And he gets in and drives away. So they go to the American and they say, same question. "How many times were you unfaithful to your wife?" And he doesn't want to answer. He's kind of embarrassed. And he says, "Look, we already know. You got to tell us." He says, 42 times. And he looks up and says, 42 times. He says, "It's a miracle you get into heaven." He says, "I don't know how I done it. You're right." And so he says, "Well, what kind of car am I getting?" He says, "Well, you're lucky you're getting a car." And so this tiny little Mini, and the guy's 6'6", appears, flat tires, doors hanging off its edges, cracked windscreen. He squeezes in and he drives away. And the next day, they're at the traffic lights, and the Scots guy's in the middle, and the American guy pulls up on one side, and the English guy pulls up on the other side. And they both look in, and the poor Scottish guy is crying his eyes out. And the American looks at him and says, "What are you crying for?" He said, "Look at the car I'm driving." And the Scots guy said, "Yeah, but I just saw my wife, and she's using roller skates."
That was good.
Oh, Rachel, you liked that joke. I can tell. Okay. Well done, everybody. I will see you Monday. Remember, this midnight, Sunday midnight, if you haven't already done so, you've got to get your homework over, and finished, because that's the cutoff date. It will disappear at midnight Sunday if you don't do it. So if you have time, and I hope you do, you can look up some of the videos that we've got. It'll give you a head start on chapter 2. It's a good idea to try and get as much homework ahead of schedule so you're not overloaded next week. And that is us. I'm going to hang about for a few minutes in case someone just wants to do a one-to-one question. Has anybody got any other questions before we say goodbye for the last time? Okay, bye-bye.
Have a good rest of your day. Bye.
Oh,
You too. Bye-bye.
I have a question on number 2 on homework 1.2. Would you be able to bring it up?
I can do that. Number
Okay.
2, homework 1.2.
Yes.
Okay, let me find that fella. Homework 2, window, try to find which window. I think it's this window I use. Yep. Okay, close that off. Homework 1.2, so I'll go back. You probably can't see this, but once I get there, I'll pop it back in
Okay.
for you. 1.2, click on it. Question 2
Yes, and B.
and B. Okay, I got it in front of me. I'm going to go out and back in, and you should be
Okay.
able to see it. That's me out. Let's see, go back in. This guy here?
Let's see. Yes, so I selected all of the check boxes,
Okay.
but I think I just wanted to double check. It didn't tell me what I did wrong.
Oh, so it
So-
did say you were wrong, but you don't know where, right?
Yes, but I have a guess
Mm-hmm.
that I wasn't supposed to select the students that are out sick, skipping class, and on the school trip because the person's only looking at a student roster, not at people in a class.
Uh-huh. Okay, well, so let's see. So the population consists of all 15-year-olds living in the attendance district. Okay. Of a local high school. Okay. You plan to obtain a simple random sample of 200 of these types of students using the student roster as your sampling frame. Right, now a sampling frame is the name you give to the people you're going to get your sample from. The sampling frame should be, if you can possibly make it, should be the same thing as the population, but sometimes it's not. And if you look at those who are in the high school roster, for instance, homeschool students will not be on that roster
Yes.
because they're not in the high school, right? So students who are skipping class can't be sampled. Yes, they can. They just might not be there that day, but you can still contact them.
Okay.
Students who are out of school trip, they can still be sampled, right? They're in the roster. You'll find them eventually. Homeschool students, they can't. Dropouts can't be sampled, right? Now, I'm assuming that in America, if you drop out your high school or you drop out your school, you're no longer on the register, right? That's what dropout means. So I'm going to put them in. Students who are out sick, well, you're still on the roster, right? So you could be picked. So what I'm ticking off here, I hope, is the two things that are correct. Homeschool students can't be sampled and dropout students can't be sampled. So were your ticks those two and somebody else, or not those two, or what went wrong?
Oh, I checked all of them, but now I think I understand.
Right. Yeah.
Yeah.
You only need to be in the roster to have a chance of being chosen. Now, you might be chosen and then they'll say, but that person skips class. Well, that doesn't mean you can't eventually catch them. They'll come to school once and you'll give them the survey to do when they turn up.
Okay.
Or you might send it to their home and that's where the survey gets done. Yeah? I've seen surveys where they send them home because, do you know, if you give students surveys to do, they never actually, somehow or other, they never actually get home. It's strange that they kind of disappear. You know, if you give Jimmy a, you have to do this survey, get your mum to fill it out for us, right, or whatever. You know that they don't always end up in their mum's desk.
No.
Strange that, right? And that's why they tend to post them, right? So I don't know how this one's done. If this one is done as an in-school one, I'm assuming that if you're sick, eventually you're not sick. And when you turn up, they give you it. And if you skip class, I'm assuming that at least one day of the week you turn up, and the day you turn up, they give you it. So you'd be able to take part in the survey eventually.
Okay, that makes sense.
Like I'm getting them wrong, and I don't know why.
Okay, so the question says, explain the difference between a simple random sample and a systematic sample, right?
Right.
So in a systematic sample, well, first things first, what we do is we go looking for a definition of a systematic sample, so that we're kind of working on a sentence that we can work with. So it's 1, 2. There's a cool little, darn it, where are you? Oh, here we are. I don't know if you can see this yet. Can you see? Yeah, can you see this other sampling techniques? Can you see that page?
No.
Okay, so I'm going to go out and in and show you that page, then we'll return to your question.
Okay.
So I'm kind of taking you through what you should probably do when this happens, and and I'm not available. You go looking for, say, and this is the PowerPoint, and it gives you a kind of summary. And in systematic sampling, then you number all the members of the population sequentially, and then you start at some random number, right, like the 5th person. And then you just do guy number 5, guy number 10, guy number 15, guy number 20. So you go through the entire population in a systematic way, right, and then a particular structure, right?
Right.
So that's what that looks like. So we're keeping that in mind. What the systematic thing does, you start it, you put everything in order. That's the first thing, right? So you have to have your population, and you have to have guy number 1, guy number 2, right? You have to put them in order, maybe alphabetically or whatever way you want to do it. And then once you do that, you then only pick some people based on every 5th person, or maybe every 100th person in the list. So we should be looking at the question again. So let's see, in a systematic sample, the clusters can be included or selected at random, and then all members of each cluster included. Now this thing uses the word cluster twice. It ain't systematic.
No.
Cluster was never mentioned in that. In a simple random sample, every sample of size n has an equal chance of being included.
I know. Okay, hold on. Sorry.
That's not a problem. In a simple random sample, then, every sample of size n has an equal chance of being included. So in a simple random sample, everybody can be included. So I'm counting that one. In a simple random sample, the clusters stop reading. It ain't happening. In a simple random sample, only samples possible are those including every k. That's not true.
No.
In a systematic sample, every sample of size n, no, that's not true. In a systematic sample, only samples possible are those including every kth item. Yes. That's basically just a regurgitation of that sentence.
Okay. Oh, I think. Go ahead.
Right? I'm just finish off in case there's more. In a simple random sample, random samples not has the word strata in it, and a simple random each strata. Right. So in all the other words, they had another term that belongs to one of the other things. So we see these strata ones, that belongs to a different kind of sampling.
Stratified.
Right. Yeah. Exactly. Right. Strata. The name is almost in the detail.
Yeah.
Right.
Okay.
Hi. What's the little guy's name?
Oh, this is Liam.
Hi, Liam.
Garbage truck. He loves garbage trucks right now. He just seen them outside.
Okay. Oh, that is a good goal. Have a.
Dada, the garbage truck is down there.
No, that's Donald Robertson. That's Mommy's teacher.
Robbie,
What did he say, Rob?
it's down there.
Oh no, his name's Liam. I told him who you are.
Oh.
The garbage truck.
Say that again?
You say that?
Garbage truck. He loves garbage trucks.
He stopped the crash.
Yes. It goes
Crash.
crash. He's my baby.
Oh, he's allowed to be. Okay, is that your only child?
I have 2 daughters through marriage as well. So I have 3 pretty much.
Okay, so this is the one you share with your partner. Okay. So the other
Garbage
two
truck
a little
is
bit
down
older.
there.
Hold on. Wait, baby.
The garbage truck is down there.
Okay.
Go find him. Go find him.
Harvest
So I guess
time.
that kind of answers my second part, number 5. I guess
Okay.
I was just getting confused. I was like, well, maybe some of them can share each other's.
Well, in this group of questions, only look for things that talk about clusters and stratified.
Okay.
And then if you go back and you read that little summary,
Mhm.
the one that talks about cluster, right? That little sentence on cluster, look for things that are just rephrasing of the same information.
Okay. Okay. So would you suggest throughout this course, like if it said like anything, I guess, if it's asked in the question or stated in the sentence, like that's what I'm going to be looking for within like these like select all
Right.
the
So
five?
yeah, this particular chapter is a lot to do with definitions and what things mean and what they are. So you can get away with basically, it's almost like, here is a phrase, I'm going to look up a dictionary to see what it means, and what these are what you would find in the dictionary if you looked up cluster sample. And if you go to the PowerPoint, there's that little page that I had where all the summary was there. That was like a nice place to go to because you don't need to go through everything. And if you read that through, all they're going to do is kind of regurgitate that type of information, maybe say it slightly differently, but essentially the same thing. So if you know what each of these kind of samples does, then you can, even if they rephrase it, you know it's the same thing.
So would you say like the first one wouldn't be considered, or in a cluster sample, random samples from each strata are included? Would that be checked because like a cluster is like taken and then little parts of the strata are taken out? Or I don't know how to explain it.
Oh, well, let's just take the first one to start with.
Mhm.
The thing that puts me off is they use the word strata.
Strata, yeah.
And clusters
Something
and
different.
stratas are kind of different. So those two don't really belong together. That's the way I would say that. Right. So when you look at a strata, what you would do here is you break the group into maybe males and females, and then you would look at each group. But you would only pick a random sample from each. So if you were going to do a sample of 1,000 people and you were using a stratified sample, you might pick 500 men and 500 women, right, out of an entire population. But you've chosen it in such a way that you've balanced males and females, right? You've got the same number. If you were doing a cluster sample, you would have different clusters. So for instance, there's 200 hospitals. You pick 5 hospitals at random. But here's the key. You ask every single person in those 5 hospitals.
Oh,
So
okay.
in one situation, who you ask is totally different. You might have 5 hospitals, but you ask everybody. In the first situation, you might have 5 things, but you only ask a small sample from each of those 5 things.
Okay, I think I was like getting confused because I thought like, so there's a stratified sample, and I thought like clusters were taking from there and then breaking it down. So I thought they were kind of two of the same.
Yeah, strangely enough, if you did something like that, it would be one of those, I can't remember what the textbook calls them, but it's something like a multi-strategy, where you do not one strategy, but you kind of do a combination of 2 things together.
Okay.
And so those are like combined, I think that might be the term they use, combined strategies.
Okay.
But none of those were that.
So much more. Like I tend to get in my brain and I complicate things way too much.
Well, stop doing that, right?
I know, brain.
Okay, you tell your brain stop doing that and things will work out fine.
Awesome. Thank you so much.
You're
Happy
welcome.
4th.
Oh, happy 4th, yes.
Yes.